Alright guys, in this video we're going to go over molar mass, how to solve for molar mass. Let's do a few example problems. So remember, molar mass is the weight of a certain element if you had 1 mole of it. For example, if you had 1 mole of oxygen, it would weigh 16 grams. Okay, I know that because I can get that from the periodic table. If you look on a periodic table, they have these little squares. If you look at the oxygen square, just underneath it has 15.998, and obviously I rounded. That 15.998 is the molar mass. I rounded and got it to 16 grams. That's how I know the molar mass of oxygen. Now, for our class, you're going to be dealing with molecules. Molecules like NaOH have more than one type of atom or one more type of these elements. So NaOH, or sodium hydroxide, has 3 different elements in this molecule. It has Na, sodium, it has an O for oxygen, and an H for hydrogen. So if I want to know the molar mass of sodium hydroxide, I have to look up all the individual molar masses on the periodic table and add them together. For example, sodium has a molar mass of 22.98. Oxygen has a molar mass of 15.999, and hydrogen has a molar mass of 1.008. Okay, I always have questions about like how many sig figs should I use, how many decimal points should I use. Okay, now what I recommend is writing them out like this, using your calculator, add it all up, and then round. Okay. Now for these numbers, I'm just going to round real quick for my own purposes to do it faster and add them up. Sodium has a molar mass of basically 23, oxygen with 16, and hydrogen with 1. So adding all those up, that would give me a molar mass of around 40 grams per mole. Okay, molar masses units are grams per mole. That means there are 40 grams in 1 mole of NaOH. Okay, and that's what molar mass means. Now, once again, I recommend adding up these numbers and then rounding them at the very end. You can do this method if you would like at certain times, like in my class, to save time. But for the AP test, I would try to use these numbers if possible. If you're running low on time, just round them very quickly and add them up. Okay. I'll do another example here. We got H2O2. This is known as hydrogen peroxide. Hydrogen peroxide has 2 hydrogens and 2 oxygens. That's what those subscripts means, which tells me then I have to add up 2 hydrogens and 2 oxygens worth of molar mass units. So I have a molar mass of 1 for every hydrogen, but I actually have 2 hydrogens, so I'm going to multiply by that by 2 to give me a total of 2. I also have oxygen, which has a molar mass of 16, but there are 2 oxygens in this molecule. So I'm going to multiply that by 2 to get me 32. Adding those 2 up, I get 34 grams per mole as my molar mass for hydrogen peroxide, or H2O2. Okay, looking at one more example. This one looks a little more complicated, and it is, but that's okay. We're going to break it down. First off, we have 3 different elements. We have hydrogen, we have P, phosphorus, and we have O, oxygen. Okay, those are my 3 elements in this. Now, there's a lot of subscripts, and sometimes we get confused on which subscript goes to which number. Okay, the easiest one to see is this hydrogen. This hydrogen has a 3 next to it. Okay, and this 2, sometimes I see a lot of students get confused. This 2 does not tell me or affect this hydrogen. This 2 only affects the elements inside the parentheses. And we'll get to that in a second. So since hydrogen is not in the parentheses, in this case, there are only 3 hydrogens, and each of those hydrogens has a molar mass of 1 for a grand total of 3. Phosphorus now, we have phosphorus inside the parentheses, which means this 2 does affect this phosphorus atom. And what you're going to do to solve and figure out how many phosphoruses you have is you take the subscript, the bottom right of it. In this case, since there's no number there, that means there's just a singular phosphorus. So there's just one phosphorus there. And I'm going to take that 2 from outside the parentheses and multiply it by the subscript right here. So in this case, I have 2 phosphorus atoms. And those 2 phosphorus atoms each have a molar mass of 30.97, but for my sake, I'm just going to make it 31 because it's a lot easier for me to do in my head. That would give me a total of 62 as the molar mass. Finally, I got to figure out oxygen, and I'm going to do the same trick. I'm going to take this 2 and multiply it by the subscript on the oxygen. That would make it 8. I multiply that by the molar mass of the oxygen, which I get from the periodic table, 16. And, oh, gotta pull out my calculator. 1 second. I'm going to take the 8 oxygens that I have and multiply it by the molar mass, which is 16. I get a total of 128. Okay, last step to find the molar mass. I'm going to take the 128, add it to the 62, and then add the 3 from the hydrogen for a total of 193 grams per mole. Okay, that would be the molar mass of H3PO4. This is known as phosphoric acid, I believe. I can't really remember now. But yeah, these are a few examples. Now, on the AP test, you're most likely not going to get a question. You may get 1 or 2 that says, hey, what's the molar mass of a molecule? Usually what they'll end up doing is they'll give you a different question where you already just automatically have to get the molar mass in order to solve that question. So basically this might be step 1 of a question, and then you have to do 2 more steps to actually answer the full question. So this is how we find molar mass. It's a very good skill, very simple skill, hopefully for a lot of us, that we can figure out very quickly.